Hello and welcome. This video targets designers willing to interface the Teledyne e2v DDR4 products with Xilinx devices. Here, the focus will be on how to set up and generate the DDR4 controller IP for the programmable logic of Xilinx devices. Apart from the technical aspects, the key message that I want to pass is how easy and fast it is to generate the IP, even for someone like me that doesn't have so much experience with Xilinx FPGAs nor with Vivado. This is thanks to our configuration files that automate almost everything. First, let's talk about what you will need to generate the IP. You will need Xilinx Vivado development tool installed on your computer. You will need our How to Generate a DDR4 Controller IP in Vivado guideline, which I will refer to as the manual throughout this tutorial, and you will need our dedicated configuration files that allow to pre-configure the DDR4 controller in Vivado. Before starting, always make sure to get the latest version of the configuration file. Now that we've listed what you will need, I would like to show you how that goes in practice. My comment is, don't worry too much if you don't understand all the details, because again, this is all detailed in this small manual and it's only a few pages. Start by opening Vivado. In this tutorial, I'm going to start from an empty project, but in practice you'll already have an existing project in which you will integrate the DDR4 controller. In my example, I don't have any files or anything to add to my project. So I'm selecting, for the example, the radiation tolerant KU60. And what I'm showing here is applicable to the other Xilinx devices of the Kintex UltraScale Plus family, such as KU115 for instance. It also applies to the other families sharing the same kind of programmable logics, such as Zinc UltraScale Plus devices. Now that my project is created, I'm simply going to the IP catalog and find the DDR4 controller IP, which is also called MIG for Memory Interface Generator. It can be found by typing DDR4 in the field. Then I right-click on it and select Customize. It takes a few seconds to open. There are many parameters to fill in this window. Since I want to be efficient, I just need to tick the box Enable Custom Parts Data File and look for the proper configuration file. Depending on the maximum operating temperature in your application, there are 3 possible configuration files. The reason is simply that the refresh rate depends upon operating temperature. Higher temperature requires higher refresh rate. Here I'm selecting the typical configuration file and I open it. Then, if I go to the components drop-down list, the DDR4 products from Teledyne e2v appear. In the manual, there is a whole list of parts available with the details on their performance. For today, I select the 1.6 GT version with no read dBi. I can now check on the other parameters. One key thing that must be ensured is that the clock specified in the memory device interface speed complies with the selected part speed. In my example, I selected a 1.6 GT/s part, and I see that the field is displayed in red, telling me that something is wrong with my configuration. The user manual tells me that for a 1.6 GT/s part, the clock should be between 1250 picoseconds to 1499 picoseconds. So if I specify 1250 picoseconds, after a few seconds, the error will disappear. Conclusion: always ensure that your clocking speed complies with the transfer rate that you have selected, otherwise the IP won't generate. Another parameter that needs to be set properly is the data bus inversion DBI mode. In my case, I have selected an option where there is no read DBI. Hence, in the data mask and DBI field, I must select one of the options without read DBI. In this field, you can also select one of the options to enable data mask, DM, and the DBI during writes, if that is desired. The rest of the parameters on the window don't need to be modified. After clicking OK, Vivado will create the appropriate directories in your project folder. As you can see, this takes a bit of time. Finally, it displays a window where you can launch the DDR4 controller IP generation. We won't generate it live since it takes some time. Once the IP is generated, it appears in the project tree and it is now usable in your design. As you have seen, by using the material that Teledyne e2v provides for its DDR4 products, the generation of the dedicated DDR4 controller IP in Xilinx devices is very easy and fast to realize. Only a few minutes are required. If you are curious to see how it works in practice, watch our other video demonstrating the functionality of our DDR4 with the Kintex UltraScale Plus KU115. Thanks for watching, and don't hesitate to get in touch with us to get the material or for more information.